Hey guys, this is Jay, and welcome back to another video. These are the concepts we'll be covering today, so let's get started. The Baeyer-Bollinger oxidation oxidizes aldehyde or ketone into ester, with oxygen insertion. The reagent used is MCPBA. So MCPBA attacks the carbonyl carbon, and the pi bond goes up, forming oxyanion. A base comes in and deprotonates the hydrogen and neutralizes the oxygen. Then the oxyanion uses its lone pair to reform the pi bond, and the carbon-carbon bond breaks. An oxygen-oxygen bond breaks and kicks off this whole leaving group. At this step, where the carbon-carbon bond breaks, there are two bonds that could have been broken. The carbon-carbon bond at the methyl group and the carbon-carbon bond at the isopropyl group. So how do we know which bond to break? We learned migratory aptitude in class. Here it means which bond is more likely to break off. From experimental results of this oxidation reaction, there's a general trend. Hydrogen is most likely to break off, then tertiary alkyl, then secondary alkyl, primary alkyl, and finally methyl. Going back to this example, so there's the methyl group and the secondary alkyl group. So the secondary alkyl group is more likely to break off. Carboxylic acid is a functional group with double bond O and OH attached on the same carbon. It's acidic because its conjugate base is resonance stabilized. A way to see if a molecule is acidic is how stable its conjugate base is. If the conjugate base isn't stable, it's less likely for the acid to donate its hydrogen away. In other words, a more acidic molecule will have a more stable conjugate base. We learned inductive effect from AA. That is, electronegative groups can stabilize the negative charge of the conjugate base by pulling electron density away. For example, this molecule on the top right. The negative charge on the oxygen is not only stabilized by resonance with other oxygen, it's also stabilized by fluorine, which is pulling electron density away. This inductive effect is stronger if the group is more electron withdrawing or more electronegative. This effect is also stronger if the electronegative group is closer to the hydrogen. So let's try a practice problem. Rank these four molecules by acidity. I recommend pausing the video really quick and trying it out. Okay, so the most acidic molecule is the one on the left, as it has two fluorine atoms pulling electron density away. Then the second most acidic molecule is the one on the right, as it has one fluorine atom. This molecule is more acidic than the third most acidic molecule because fluorine is more electronegative than bromine, which makes this inductive effect stronger. Finally, the third most acidic molecule is more acidic than the least acidic molecule because the bromine is closer to the hydrogen on this molecule versus the other molecule. If carboxylic acid is a substituent on the aromatic ring, then other substituents on the aromatic ring can also affect its acidity. So EWG can make the carboxylic acid more acidic as it pulls away electron density, and EDG can make the acid less acidic as it donates electron density. So let's try another practice problem. Rank these molecules by acidity. The molecule on the left is most acidic because it has an NO2, which is an EWG that pulls electron density away. The molecule on the right is least acidic because it has an EDG, the ethyl group, which donates electron density. The middle one is second most acidic because it doesn't have an EDG or EWG. We review some ways of making carboxylic acid. So we have benzoic oxidation using the Jones reagent. We have oxidation of aldehyde, oxidation of primary alcohol, and ozonolysis of alkynes. The ozonolysis reaction cuts the molecule in half and forms carboxylic acids. We talked about carboxylation of Grignard reagent. So we use a Grignard reagent to nucleophilically attack the carbon. Then we form this deprotonated carboxylic acid. Then this negative oxygen will grab a hydrogen from water and forms carboxylic acid. Thank you guys for watching. The next video will be delayed to Saturday, so I can also include Friday's lecture. Thank you guys so much.